This is the solution video for section 6.4, problem number 7. All right, so I have the integral of e to the x minus e to the negative x over e to the x plus e to the negative x with respect to x. All right, so I look at this, and some people, try to split it up or whatever, but remember, you've got that addition sign in the denominator, so you cannot split this up into separate fractions. And so what we want to do is we want to choose a u substitution. Okay, now, when you have a numerator and denominator situation like this, generally speaking, the denominator is the better choice. Why? Well, because if I choose the numerator, I don't have the denominator times dx. I have 1 over the denominator times dx. And so that's not going to work. But if I choose the denominator, I do have the numerator times dx. All right. So I have, once again, 1 over u, because I chose the denominator as u. And then I have e to the x minus e to the negative x dx. All right, so now I need to take the derivative of u. So what is du? Well, derivative of e to the x is e to the x. And then I have plus the derivative of e to the negative x. But what's the derivative of e to the negative x? Well, it's e to the negative x times -1, so it becomes minus e to the negative x. And then all of that times dx, which is what you have here. So I have the integral of 1 over u du. And so integral of 1 over u du is natural log of the absolute value of u plus c, and the absolute value of u, so I have e to the x plus e to the negative x plus c. So now, once again, we want to consider what's inside of the absolute value, e to the x plus e to the negative x. Well, what is e to the x? E to the x is a graph that looks like this. E to the negative x is actually just a graph that looks like this. And so if you add these two things together, which are always positive, you are going to get a value that's always positive. And so you do not have a need for the absolute value. So it's e to the x plus e to the negative x plus c.